Okay, 1 second, I will be with you. Okay, now just let me remind you what we've been talking about in module 1. We started with calculus and linear algebra. The first topic was vector calculus. We already discussed this, and then week number 3 we started a new topic, which is matrices. We define matrices, we classify them, we talk about the operations of matrices, addition, subtraction, multiplication, and determinant. And today we will continue with this until we reach the point where we use matrices to solve set of equations. Okay, so I will revise a few things related to matrices because I need them here, and then we go for solving set of linear equations. First of all, remember determinant, we say each matrix have its own determinant, which is a unique number, and there are some properties good to be considered here. Okay, one of them, I will take them one by one because these properties we will use them later on in our solution for set of linear equations or differential equations. I will read and explain to you each one of them. The first one is saying that the value of the determinant remain unchanged if its rows and columns are interchanged. Okay, I mean the determinant, you can see here what happened is this, the first determinant here, I change the rows into columns. You see, rows into columns, rows into columns. What we call this transpose, right? It seemed to be when I change them, still the determinant is equal to the determinant of the transpose. Nothing changed. So it doesn't matter if we change the rows into columns or columns into rows. Okay. The second property, if any two rows or columns of a determinant are interchanged, then the value of the determinant is changed by minus sign. It means, see this red row, I will make it from row number 1, R number 1, it will be R number 2 here. And the R number 2 in the determinant, I will change it to be R number 1. So changing any two rows will not change the value, will change only the sign, the same value. If it is 7, it becomes minus 7. If it is minus 7, it becomes 7. We only change, you see here, row number 2 become row number 1, row number 1 become row number 2. Nothing changed excluding the sign of the determinant, the value. Another point, if I multiply, if all elements of the row, okay, or column is multiplied by non-zero number, scalar number k, then the value of the new determinant is k times the value of the original determinant. So you see here in this row, I multiply each element by k. What this will do to the determinant? The same determinant, just multiplied by k. So this is the only effect on the determinant. Okay. Now the same thing could be say if I multiply, divide, rather than multiply, I divide. Okay. Also, it will not change the determinant. We just need to divide the determinant by the new number. Also, we discussed. Please mute your mic, please. Okay. Now just let me remind you with addition, subtraction, multiplication of matrices. We mentioned that if we have two matrices A and B and they have the same dimension, as you can see here, 3 by 3, we can add them, we can subtract them easily. Each item with identical item in the same position. 8 plus 7 give me 15. Minus 2 plus 2 give me 0. As example, 6 plus 6 give me 12. So we just need to add, the same thing could be say for subtraction, 8 minus 7 give me 1, and so on. For the multiplication, we need to make sure that, as example, this is A and this is B. Okay, the dimension is 2 times 4 and here 4 times 3. The internal dimension should be the same. I mean, column here should equal to row here. And the new determinant will be 2 times 3. This is the 3, this is the 2. You got it? How we do this? Very easy. Row number 1 by column number 1. It gives me the first, it means multiply 1 by 2 plus 2 by 6 plus 7 by 6 plus 9 by 2. Supposed to give me 74. First row by second column. Again, 1 by minus 2. 2 by 0. 7 by 9. 9 by 4. It gives me the second number. And so on. We need to be careful here, because you know many numbers. You know, I know that you it is easy for you to add, subtract, multiply. These are easy stuff for you, but because there are many numbers, make sure to do them correctly. Don't jump. Don't jump. Let me say steps. Work in steps. Okay. Now, determinant, you remember also we mentioned that there are three methods used to find the determinant: cofactor expansion, row reduction, and cross product. And I know that you are familiar more with the cross product, you enjoy with the cross product. As example, this matrix, you bring it here, you put it here in this way, and you copy the first and second column, you put them here, okay, and then you start multiply with positive sign, multiply with positive sign, multiply with positive sign. The same thing here, you multiply with negative sign, you multiply with negative sign, and then you do the math. I know it is easy for you, you can do it, okay? So this is the cross product. For cofactor expansion, this one, you can do this expansion through any column or any row and find the determinant. But just let me remind you with cofactor how we find it. The cofactor is simply Cij, its formula minus 1 to power I plus j mij, where m is the minor of the cofactor, minor ij. As example here, let me take this one. C2, 3, it means row number 2, column number 3. So this is row number 2, this is column number 3. So we are talking about here, this value. Okay, so we will say minus 1 to the power 2 plus 3. Okay, and since these have to be hidden, then what is left? 2143. 2143. Now do the determinant to find the final answer. For each element there is cofactor. Okay. Also, another property for determinant, I'm just revising the property with you, then we will use some of them later on, and we will prove also some of them. If each element of any row or column consists of two or more terms, then the determinant can be expressed as sum of two or more determinants. As example, you see this column contains two items, a1 plus x, a2 plus y, a3 plus z. The determinant for the whole matrix, okay, here, can be split by splitting these parts, as you can see here, and plus determinant of these parts with the others, right? So this is another property can be used in determinant, okay? Another point number 5, the value of a determinant is unchanged if any row or column is multiplied by a number and then added to any other row. What does this mean? Have a look. I will keep column number 3, column number 2 without change. I will not touch them. But what I will do to column number 1, I will change its value, okay, column number 1, you see here, to be column number 1 values plus m times column number 2 minus n times column number 3. Okay, it means a1 plus m by column number 2, which is b1, minus n by column number 3, and I do the same thing for other items. You tell me, okay, nothing will change? Yeah, nothing will change. This is what we are saying. Multiplying, adding, subtracting column from column will not change the determinant. We keep it without change. Now, another property, if any two rows of a determinant are identical, then the value of z, okay, of then the value is 0. Okay, have a look here. You can see these two rows. Please mute your mic, Isa, please. And the second row here, your mic, please. Please mute your mic. please mute your mic. Qusay. Okay. We will lose focus if anyone, we will lose focus, please. So again, the first row here, you can see it's equal to the same row here. Items are the same. Then this what will lead to be to get zero identity determinant. Another one, if I have any row or column have zero items, then the determinant will be zero. And last but not least is if the matrix is diagonal, as you can see here, diagonal matrix, it means other elements excluding diagonal will be zero. Then the determinant is multiplication of these items. Okay, it means A by B by C. It's easy. Here we don't need to do calculation. Directly multiply A by B by C. Now let's take example on cofactor expansion. Cofactor expansion, see this matrix here. What I will do, I will find it for column number 1 or number A on this column. Okay, then I will come to say 3 with positive sign minus 2, the second item, plus 5. Now we understand this minus came from where. Okay, now next I will do the determinant. As example, for 3 here, you hide this row and this column. What is left? These 4 elements, I put them to find the determinant. The same thing for the second and the third item. Easy to find it. If I take any other column or any other row, I will have the same value. Sometime we need to be smart in selecting which column or row to do the determinant. As example, in this matrix, definitely we'll say, okay, column number 2 is the best because it contains 3 zeros, only one number. So it makes my task easy. I advise you to solve it when you're back home. Now let me prove some of these properties and I will go to the point I would like to talk about today. Okay. Now row reduction, the third method. Let me explain what the meaning of row reduction. Okay. Now if I have matrix A, C, B, D, then you say determinant of matrix is multiply this minus this, as you can see here. What if I change row number 2 to be row number 2 plus K times row number 1? It means I will come to A, here I will say KA and here KC. Then I will add them to B. It will be plus KA, D plus KC. What this will do to my determinant? Okay, I will come here, multiply these. We are here. So open the brackets, multiply here and here. As you can see, we are here. Simplify, cancel each item, return here. Let me check this value with this value. Is there any change? No. Oh, so determinant, if I add, subtract any row from any other row or any column from any other column, multiply by number. Okay, this will not change the determinant. Yes, this will not change the determinant, as we prove it here. Now for row reduction, it's useful property. We can use it to simplify our task. As example, see this matrix here. Okay, he want me to find the determinant. What I will do, I will try to simplify the task. Let's see. I can see here 7 and 3 are similar to these. So let me change row number 2 to be row number 2 minus row number 1. It means I will keep row number 1, as you can see here. Row number 3, I will keep it. The change will happen only to row number 2. How? As I mentioned here, 2 minus 1, 1. 7 minus 7, 0. 3 minus 3, 0. This will not change the determinant, as we explained in the property. Okay, as we prove it also. Now you may say, okay, what is the benefit of this? The benefit, I can find the determinant easily, because if I take this row, okay, then we will have, this is the second number, so it will be minus rather than 1, and the determinant of the minor, these two numbers and these two numbers, just multiply them. We got the determinant. So sometimes we can use row reduction to simplify the solution. You got it? Okay. let me prove also here another property. You see here A, C, B, D. Okay, the determinant, just multiply them. We got this one similar to the previous slide. Now interchange 2 with row number 1. Change them. This one will be here. This one will be here, as you can see here. Undo the determinant. We got this part. Take minus as a common. We return here. See, this one is equal to this one. What does this tell me? Changing rows, interchanging rows or columns will lead to have the same determinant but with opposite sign. Another property to be proved. Have a look here. This is always the base. The base is A by D, C by B. We got it here. But let's replace row number 1 by multiplied by K. It means KA, KC. Now let's do the determinant in this way. Simplify, take K as a common. We are here. What is left? The same determinant multiplied by K. So if I multiply any row or any column in the determinant, its determinant will not change, just we multiply it by the constant. Okay. Now another example on using row reduction. See this determinant here. You want me to find the determinant for this matrix. Okay. I will replace row number 2, it means this row. Okay. To be row number 2 plus 3 times row number 1. It means, have a look. Let me write here. 3, we say minus 3 by row number 1. It will be minus 3 by 1 minus 3. Minus 3 by 4 minus 12. Minus 3 by 6 by 2 minus 6. Let me change the color so I can work. Okay. Now first of all, row number 1 will not change. We don't touch it. Row number 3, we don't touch it. As we say here, we change only row number 2. So I bring them, I put them here. This is 1 and this is 3. I didn't touch them. Now I will say that row number 2 plus 3 times row number 1. So 3 plus minus 3, it will give 0. 10 plus minus 12, it gives minus 2. 8 plus minus 6, it gives 2. You see? This will not change the determinant as we agreed. Now next, what I will do, I will change row number 3. When he told me change row number 3, it means keeping row number 1 and row number 2 without change, as you can see here, without change. Only row number 3 will be changed. Okay, let me change the color here. Okay, again red. Row number 3 will be 2 times row number 1. So I will change here row number 1 2 times. It means 2 by 1, 2. 2 by 4, 8. 2 by 2, 4. Okay, row number 3 will be minus 2 plus 2, 0. Minus 7 plus 8, 1. 5 plus 4, 9. Now you tell me, okay, you did this. What is the benefit of the end? Have a look. I make it only one number, 0 here, 0 here. So I can find the determinant directly. It will say that it is 1 multiplied by its minor directly. So for it's use this row reduction use to simplify to find the determinant directly. Okay, but what I'm looking for is to use it in a better way, as I will show you in the next few slides and the technique. Let me start first with defining a joint of a matrix. A joint of matrix A. If I have matrix M by N, so directly we'll say, okay, this is a square matrix. Agree. How we find the adjoint of matrix A? It's defined here. Adjoint of matrix A is, you see here, cofactor matrix, transpose of cofactor matrix. It means I go for A, I find its cofactor matrix, then I do the determinant. Let me show you. I will come to each element. We have here how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. Each one of them, I will find its cofactor. We have one formula, Cij equal minus 1i plus j mij. I will apply it for each one of these items. As example, I will come to this one, This one is C11, row number 1, column number 1. Minus 1 to the power 1 plus 1 and M11. This is 1 plus 1, 2 minus 1 to the power 2, 2. Sorry, 1. So it means positive sign. Let me come to M22. It means this number. I multiply them. I got minus 2. So I got C11 equivalent to this A11. I do the same. C12, 13, 21, 22, 23, 31, 32, 33, 9 components. Then I put them. C11 will be in this place. C12 will be in this place, and so on. What we got? Cij. Now I will come to the final answer. I will say adjoint of A is the transpose of cofactor. It means this row become column number 1. Row number 2 become column number 2. Row number 3 become column number 3. Now adjoint, is it clear? Is it clear, the adjoint? Great, great. Thank you. So let's go to use it in what we call it inverse matrix. Don't forget, I'm taking you through matrices. The end is to solve set of equations, linear equation, differential equation, doesn't matter. We will see this later on. But all this discussion going there. Okay, now let me come to inverse of matrices. If I have two matrices A and B, and I multiply them and I got identity. You remember identity? It is diagonal matrix with ones in the diagonal. Then if I got identity I, then we call A and B, one of them is the inverse of the other. It's very easy. A is equal to B inverse or B equal to A inverse. Because of this, because they are inverse to each other, then we got the identity. Okay. Now let me start the definition for to clarify this. If I have two matrices B and A, both of them have the same dimension 2 by 2. They are square matrices. If I multiply them, this is A and this is B. We know how to multiply this row by this column, this row by this column, this row by this column, this row by this column. I got this. Just have a look here. It is identity. What does this tell me? That B is inverse of A. Let me multiply B by A. I did the same thing. I got also identity. They are inverse to each other. You got it? Okay. We understand the inverse. How we find the inverse of a matrix? Sorry, few methods. Method number 1, or theorem number 1. It's applied for 2 by 2 matrix. 2 by 2 matrix. If I have matrix A, B, C, D in this way, and this matrix have a determinant, this determinant is not equal to 0, then its inverse will be 1 over its determinant. We know how to find it, AD minus BC. Then multiply by the determinant here, which you see these two elements A and D, we interchange them. Each one take the place of the other one. While B and C, we keep them in their position, but we change their signs. Okay, this is the theorem. Let me apply it here. I will say, let me find determinant of A. 5 by 4, 20 minus 3 by 2, 16 equal to. Okay, great. So I got the determinant here. You see here, 1 over 2. And next, I will open here in this way. 5 and 4, they interchange their places. There, 5, 4 here, 5 here. 3 and 6, they have the same place, but with different sign. You got it? This is the inverse of matrix A. It's easy, but it's applied only for 2 by 2. Theorem number 2 say we can find determinant of matrix by using what we call it adjoint. You see here, inverse of matrix A is adjoint divided by its determinant. See this matrix? We just, in the previous slides, we found its adjoint. This is the adjoint. Okay, and its determinant is 60. So 1 over 60 by its adjoint. Very easy and straightforward. Yeah, it needs time to do the calculation, but at the end, the idea is clear. Another method, theorem number 3, is what we call it row reduction. We use elementary row operation or the idea of row reduction. How this work? Have a look. You see here, we will put our matrix A, the one, oh, just a minute, okay, the one that we want to find its inverse with a line here, and we put here identity having the same size. And I use elementary row operation, which is row reduction as example, then to change the situation from A to I into I to B. I will explain it through example, it will be easy. How we do this? By interchanging rows or columns, or multiply row by scalar and add or subtract from column and so on. The properties we just been defining. Let's apply this idea on this matrix. You want me to find this matrix, the inverse of this matrix. Now, I just want you to stay with me, focus on this example. It's easy, but we need to be careful. Have a look. As I mentioned in the definition, I put A slash I. It's 3 by 3, then this one should be 3 by 3. As you can see, this is my original matrix, and this is the identity. As you can see here, 1, 1, 1, 0 everywhere. Okay? Now, it's easy to put them together. Okay, let me erase this because I need it to be clean. Okay. What I will do, the matrix here, I will try to change it to make it identity. It means diagonal ones, everything else zeros. So I work based on this. How can I do this? It means, have a look, have a look. I will change this one to be 0, 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 and this one it will be 1, this one it will be 1. When I reach this situation, I will say, okay, here is my inverse. You got it? How I can do this, I will explain now. Okay. Let me change the color. Sorry. Okay. Now first, I want to make this 3 0. So what I will do, I will change only R2. I will say R2 will be changed to be R2 minus 3 R1. Why? Because if I multiply here by 3, 3 minus 3, it will give me 0, as you can see here. You see? For that, I will change R2 to be R2 minus 3 R1. Since I'm changing only R2, then R1 will not change. 1, 4, minus 1, 1, 0, 0, 1, 4, minus 1, 1, 0, 0. And row number 3 will not change. 2, 2, 3, 0, 0, 1, 2, 2, 3, 0, 0, 1. I keep them. But here to change R2 to become R2 minus 3 R1, I need to multiply by minus 3. Minus 3 here, minus 3 by 2, minus 12, minus 3 by minus 1, 3, okay, minus 3 by 1, minus 3, minus 3 by 0, 0, and then here also 0. Okay? Now let me do the calculation. 3 minus 3 will give 0. 5 minus 12 will give minus 7. 2 plus 3, 5. 0 plus minus 3, minus 3. 1 plus 0, 1. 0 plus 0, 0. This is the first step. Is it clear how I change it? Is it clear? Ladies, gentlemen? Okay. Let me erase this part.
Again, yes.
Again? Again? Okay, again. You just need to understand the first step. If you understand it, the remaining is just repeating what we are talking about. Now, what I will do, I want to make this 3 to become 0. So what I will do, I will multiply here by minus 3 and then I add. Minus 3 by 1, minus 3, minus 3 by 4, 12, minus 12, minus 3 by minus 1, 3, minus 3 by 1, minus 3, minus 3 by 0, and by 0, 0. Then I will change this one. I will add 3 minus 3, 0. 5 minus 12, minus 7. 2 plus 3, 5. 0 minus 3, minus 3. 1 minus plus 0, 1. 0 plus 0, 0. This is the first step, and I did it. I make this 0. Now I want to make 2 to be 0. I will not touch row number 1 and number 2. I will keep them. You see? I only will change here row number 3. Row number 3 will be row number 3 minus 2 times row number 1. Because if I multiply here by minus 2, 2 minus 2 to give me 0. Then minus 2 by 1, minus 2 by 4 minus 8, minus 2 by minus 1, 2, minus 2 by 1 minus 2, and here by 0, 0 by 0, 0. Then I will add 2 minus 2, 0. 2 minus 8, minus 6. 3 plus 2, 5. 0 minus 2, minus 2. 0 minus or plus 0, 0. 1 plus 0 is 1. You see? Got it? Is it clear?
Yes, Doctor.
Clear.
Great,
Yes.
great, great, great,
Yes.
great. Let me erase this. Okay. Okay. Now, just to remind you, I changed this to 0, and I change in the second step this to 0, so I have 2 zeros. Okay, I want to change this into 1. So definitely you will say, okay, divide this part by minus 7. Everything here. So I keep it. You see, this one, I keep it. I didn't touch it. Row number 3, I didn't touch it. What I did, I changed R2 to be minus 1 over 7 R2. So divide it, divide by R2. This one divide by minus 7, by minus 7, by minus 7, by minus 7, by minus 7. I'm here. You see, this is my change. Next, I want to make this minus 6 to become 0. You see, I will say, okay, R3 will be R3 plus 6 times R2. Because if I multiply this row by 6, 1 by 6, it will be 6 minus 6 plus 6, it will be 0. I got it. Now next, okay, I will change, now I reach here, okay, I will change now this 4 into 0. You see, I will say, okay, row number 1 will be row number minus 4 times row number 2. I change it to 0. I don't need to go into details now. It's clear because we are doing the same process. Okay, now I want to change, after that I want to change this number into 1. What I do, I will multiply here by 7 over 5, the whole row. Okay, so this one with this one, this one with this one, is what is left, 1. Now next I want to change this value to be 0. Okay, I will say, okay, it will be R2 plus 5 over 7 R3. I change it to 0. You see my change here and here and here and here and here and here. What is left? The last one here. I will say, okay, R1 will be changed to be R1 minus 13 over 7 R3, because here it's 1. I will multiply it. Okay, then I got it 1. Have a look here. What we see here, this is identity. Okay, this is identity slash this new matrix represents the inverse. This is the new matrix. This is the inverse of matrix A. You got it? Clear?
Yes.
Great.
Now,
Doctor,
Yes.
this before the R3 or the